In this experiment, the importance of memory accelerate module is shown. This is the program for flashing LEDs connected at port 1 bit 16 to 23. The only difference is that if the analog to digital conversion is less than 80 in hex, then the memory accelerate module is enabled, otherwise it is disabled. Debug. So for the first case, I am entering analog input at channel 0 equal to 0.1 and stepwise executing. The port 1 bit 16 to 23 are set as output. The VLSI peripheral bus is enabled. The A to D converter is initialized and enabled as well. The execution remains in do while loop until the conversion is completed. The conversion is completed now, and the if else statement is used to check whether the value is less than 80 in hex. For analog input 0.1, since it is less than 80 in hex, so therefore this group of statements will be executed. This is the timing register for the memory accelerate module. This tells the number of CPU cycles required to fetch from the flash memory. This is the control register. Since it is equals to 2 in hex, the mode is fully enabled for memory accelerate module. The for loop creates a delay. This function is used to set and clear the LEDs. Stepping into this function, since it is the first run, the bit 16 of port 1 is set. And the execution again reaches here. Thus, if I simply run this program for analog input of 0.1, the LED is connected from bit 16 to 23 blink once in sequence, and it can be seen that this group of statements are executed. That means the memory accelerate module is enabled. Now let us observe for analog input 1.5. I have entered here analog input equal to 1.5 in channel 0 in the A to D converter peripheral window. Stepwise executing. The execution is in do while loop. It will wait for the conversion to be completed. Since the conversion is complete, stepping over, we can see that since the conversion is greater than 80 in hex, so therefore the else statement will be executed in which the memory accelerate module is disabled. Again a delay is generated. This is the function to set the LEDs. So the flasher, that is the shift of the active LED happens, and this checks for overflow, and again all the statements are executed. Simply running this program and observing, it can be observed that bit 16 to 23 are set in sequence with memory accelerate module being disabled.